Okay, so we are continuing on with the lesson from yesterday, which is just exactly as you see it, but we are going to have some problems where you require a slip and slide factoring. So for instance, number one, we always check to see if there is a GCF. If there is not, and there is a leading coefficient, then it is a slip and slide. If there is, and we bring it out, then it becomes a basic trinomial. So number one, 3, 9, and 12 have a GCF of 3. So I'm actually left with x squared plus 3x minus 4. So then it becomes a basic trinomial with the 3 still out inside. So we're going to break it up into two binomials where x times x is x squared. And since c is negative, that means one's going to be positive, one's going to be negative. And since what multiplies to get 4 but subtracts to get 1, remember, read it backwards, multiplies to get 4 but subtracts to get 3, I apologize, is 4 and 1, where 4 is the bigger number, so it has to go with the sign that the b is, so 4 has to be positive and 1 has to be negative. And then we're going to set all of this equal to 0. So 3 does not equal, when I set 3 equal to 0, does not equal 0, so it's not a solution there. But I'm going to set up x plus 4 equal to 0 and x minus 1 equal to 0. When I solve for x, I'm going to subtract 4 here, so my first x-intercept is going to be negative 4. On the second one, I'm going to add 1 to both sides, so my second x value is positive 1. These are my two x-intercepts, which you will see written as a list in curly parentheses, so negative 4 and positive 1. Number 2, all three terms have a GCF of 5, so when I bring that out, I have x squared minus 4x minus 12 equals to 0. Again, this is a basic trinomial after I bring out the GCF, so I can break it up into two binomials where x times x is x squared. Then since c is negative, that means one's going to be positive, one's going to be negative. What multiplies to get 12 but subtracts to get 4? And the two numbers that come up are 6 and 2. Since 6 is the bigger number, that means it has to be the sign that b is. So 6 is negative and 2 is positive. I don't set the 5 equal to 0 because 5 does not equal 0, so it's not a solution. But x plus 2 equal to 0 and x minus 6 equal to 0. When I solve for x on the first one, I'm going to subtract 2. So my first x-intercept is negative 2. When I add 6 on the second one, my second x value is positive 6. So as I write it as a solution list in the curly parentheses, my two solutions are negative 2 and 6. Number 3, this one does not have a GCF because 2, 3, and 5 do not have a common factor. So this is a slip and slide. If you remember how to do the slip and slide, we are going to slip the 2 to the 5 by multiplication. So it becomes x squared plus 3x minus 10. And remember, we're going to slide this back later, so we got to remember it's still there. So then I treat this like a basic trinomial where I break it up into two binomials where x times x is x squared. Since c is negative, that means one's positive, one's negative. What multiplies to get 10 but subtracts to get 3, the two numbers that come up are 5 and 2. Where 5 is the bigger number, so it has to go with the sign that b is, so 5 has to be positive and 2 has to be negative. Now this is where I'm going to slide that 2 back as a denominator for both of these terms and simplify if I can. This one, 5 over 2 does not simplify, so I'm going to slide the 2x plus 5. 2 over 2 simplifies to 1, so this binomial ends up being x minus 1. Now I'm going to solve for 0. So I'm going to set the first one equal to 0, 2x plus 5 equals 0. When I solve, I'm going to subtract 5 and then divide by 2. When I divide by 2, it's going to stay a fraction, so my first x value is negative 5 over 2, or written as a decimal if you prefer is negative 2.5. And then I'm going to set x minus 1 equal to 0, where I'm going to add 1, so my second x value is positive 1, and those are my two solutions. Number 4 does not have a GCF, so I have to slip the 8 to the 5. So it becomes 8x squared minus 22x plus 40, where now it becomes a basic trinomial where I can break it up into two binomials where x times x is x squared. What multiplies to get 40 but adds to get 22, and the two numbers that come up are 20 and 2. Since C is positive, that means I'm going to have the same sign. That means they're both going to be negative. And since it doesn't matter where I put the 20 and the 2 because they are both negative. But remember, we have to slide this 8 back. So I'm going to divide by 8 on both binomials. Simplify where needed. So 20 over 8 simplifies to 10 over 4, which then simplifies to 5 over 2, because 4 goes into both. And then 2 over 8 simplifies to 1/4. So then it becomes, I'm going to slide this 2 to the front, 2x minus 5 and 4x minus 1, where I'm going to set both of them equal to 0. 2x minus 5 equal to 0 and 4x minus 1 equal to 0. So I'm going to add 5 to both sides. So 2x equals 5 divided by 2. My first solution is going to be 5 over 2. On the second one, I'm going to add 1. And so I have 4x equals 1 divided by 4. And my next solution is going to be 1/4. As decimals, this would be 2.5, and this would be 0.25. Oh my goodness. Okay, so now we're just going to practice a few. I'm going to probably make 2 separate, well, no, I have to put it all together. But anyway, if you want to continue watching, it's going to be just like yesterday and with a few slip and slide examples. So if I look at number 1 at the bottom, it's already set equal to 0. We always check to see if there is a GCF. So the GCF here would be 2, which I'm left with x squared plus 5x plus 4 equals 0. And then now it becomes a basic trinomial, so it is not a slip and slide even though it looked like it initially. So now that I can break this up into 2 binomials, where x times x is x squared, and then since C is positive, that means they're both going to be the same. B tells me that they're both going to be positive. So what multiplies to get 4 but adds to get 5? The two numbers that come up are 4 and 1. Doesn't matter where I put the 4 and the 1 because they are both positive. Now I'm going to set everything equal to 0. 2 does not equal 0, so that's why 2 is not a solution. But when I set x plus 4 equal to 0 and x plus 1 equal to 0, I subtract 4, so x equals -4 is my first solution. On the second one, I'm going to subtract 1, so my second solution is -1, whereas I write it as a list, -4, -1. Number 2 does have a GCF of 4, so if I pull out that GCF, it becomes x squared minus 6x minus 7. Now it's set equal to 0. Now it becomes a basic trinomial where the GCF is out in front. So we have 2 binomials where x times x is x squared. Since C is negative, that means one's going to be positive, one's going to be negative. What multiplies to get 7 but subtracts to get 6, and the two terms that come up are 7 and 1. Where 7 is the bigger term, that means it has to be the sign that B is. So 7 has to be negative and 1 has to be positive. Now I'm going to set everything equal to 0. 4 does not equal 0, so it's not a solution, but x plus 1 equals 0 and x minus 7 equals 0, where I'm going to subtract 1, so my first x-intercept is -1. Here I'm going to add 7, so my second x-intercept is +7, where you'll see it written as a list, -1, 7. Number 3, this one does not have a GCF, so that means it's going to be a slip inside because that 3 out in front. So that means I'm going to slip the 3 to the 10, so it becomes x squared plus 13x minus 30. Now it becomes a basic trinomial, so x times x is x squared. Since C is negative, that means they're both going to be different, and B tells, or it's going to be positive, negative. What multiplies to get 30 but subtracts to get 13? And the two numbers that come up are 15 and 2. Since 15 is the bigger number, it has to go with the sign that 13 is. So 15 has to be positive and 2 has to be negative. Though don't forget, this was a slip and slide, so we need to bring this 3 back. 15 over 3 simplifies to 5. 2/3 does not simplify. So my first term is x plus 5. My second one is 3x minus 2 because this denominator moves to the front. Now I'm going to set both of them up equal to 0. So on the first one, I'm going to subtract 5. So my first intercept is negative 5. On the second one, I'm going to add 2 and then divide by 3. So it ends up being a fraction of 2/3, which written as a decimal would be 0.6 repeating. I'm going to finish this one more and then the video will continue. So here, this one does not have a GCF, so it is a slip and slide, which means I'm going to slip the 5 to the 3 by multiplying. So it's x squared minus 8x plus 15 equals 0. Now it becomes a basic trinomial, so x times x is x squared. Since c is positive, that means they're both going to be the same, which means they're both going to be negative according to the b value. What multiplies to get 15 but adds to get 8, and the two terms that come up are 5 and 3. It doesn't matter where I put the 5 and 3 because they're both negative. Now the 5 that we slipped has to come back as the denominators. 5 over 5 simplifies to 1. 3/5 does not simplify, so I'm going to slide that denominator to the front. So it becomes x minus 1 and 5x minus 3. Okay, then I'm going to set both of them up equal to 0. So then to solve for x here, I'm going to add 1. So my first x value is positive 1. Here I'm going to add 3 and then divide by 5. So it ends up being 3/5, which is equivalent to 0.6. Okay, so this is just more practice of finding solutions by factoring. So number 5, it's already set equal to 0. We want to look for a GCF, which in this case does not have one. So since there is a leading coefficient, we're going to slip that 3 to the 15, where we have x squared plus 14x plus 45, 45. Now it becomes a basic trinomial, which we can break up into two binomials, where x times x is x squared. Since c is positive, that means they're both going to be the same, and b tells me that they're both going to be positive. So what multiplies to get 45 but adds to get 14, and that would be 9 and 5. It doesn't matter where we put the 9 and the 5 because they're both positive, but this was a slip and slide, so we need to bring that 3 back as a denominator. 9 over 3 simplifies to 3, and 5 over 3 does not simplify, so we're going to slide that denominator back to the front. So this first binomial is x plus 3. The second binomial will be 3x plus 5. And now we're going to set both of them equal to 0. So x plus 3 equals 0. We're going to subtract 3 to get x by itself. So my first x-intercept is negative 3. The second binomial, 3x plus 5 equals 0. We're going to set equal to 0. We're going to subtract 5 first, where we have 3x equals negative 5. We divide by 3, which in turn stays a fraction, or if you want to convert that to a decimal, is negative 1 and 2/3, which is negative 1 and 1.66666 repeating. So my two solutions at the very end of it will be negative 3 and negative 5/3. Okay, number 6, there is no GCF, so it's also a slip and slide because of this 2 out in front. So we're going to slip the 2 to the negative 7. So it becomes x squared plus 13x minus 14. Then it becomes a basic trinomial where I can break up into two binomials where x times x is x squared. Since c is negative, that means one's going to be positive, one's going to be negative. What multiplies to get 14 but subtracts to get 13? The only two terms that work is 14 and 1. Since 14 is the bigger number, that means it has to go with the sign that b is. So 14 has to go with the positive and 1 has to go with the negative. Since it was a slip and slide, that means I've got to bring this 2 back as a denominator. 14 over 2 simplifies to 7, and 1/2 does not simplify, but the 2 is going to bring back as a leading coefficient. So this one ends up being x plus 7, and the second one ends up being 2x minus 1. We're going to set both of them equal to 0, so x plus 7 equals 0. To solve for x, we're going to subtract x. So my first x-intercept is negative 7. Then we're going to set 2x minus 1 equal to 0, where we're going to add 1 first, and then 2x equals 1. We're going to divide by 2. So the second x-intercept is 1/2, which is 0.5. So my two x-intercepts is negative 7 and 1/2. Okay, number 7 is has no GCF, and so we're going to have to slip and slide that 5 to the 4, where I have x squared minus 21x plus 20. And then it becomes a basic trinomial where I can break up into two binomials where x times x is x squared. Since c is positive, that means they're both going to be the same, which means the b tells me they're both going to be negative. And then what multiplies to get 20 but adds to get 21, that would be 20 and 1. Since they're both negative, it doesn't matter where I put the 20 or the 1. And then since it was a slip and slide, I got to bring that 5 back and then simplify where needed. So 20 over 5 simplifies to 4. 1/5 does not simplify, but that denominator is going to go back to the front. So this one ends up being x minus 4, and this one ends up being 5x minus 1. I'm going to set both equal to 0. So x minus 4 equals 0. We're going to add 4. So x equals 4. Here we're going to do 5x minus 1 equals 0, and we're going to add 1, then divide by 5, which ends up being 1/5 as my second x-intercept. So my two x-intercepts are 4 and 1/5 as a list. Number 8, there is no GCF, but it is a slip and slide because of that 6 out in front. So we're going to slip the 6 to the 1. It becomes x squared plus 5x plus 6. It then becomes a basic trinomial, which I can break up into two binomials where x times x is x squared. Since c is positive, that means they're both going to be the same. And since b is positive, that means they're both going to be positive. What multiplies to get 6 but adds to get 5? The two terms would be 3 and 2, where it doesn't matter where I put the 3 and the 2 because they're both positive. Since it was a slip and slide, we're going to bring the denominator of 6 back. They both simplify. 3 6 simplifies to 1/2, and 2 6 simplifies to 1/3. So the 2 is going to slide back to the front, and the 3 is going to slide back to the front. This one ends up being 2x plus 1. This one ends up being 3x plus 1. I'm going to set both of them up equal to 0. So 2x plus 1 equals 0. We're going to subtract 1 and then divide by 2. So x equals negative 1/2. And then we're going to set 3x plus 1 equal to 0, where I'm going to subtract 1 and then divide by 3. So my two x-intercepts are negative 1/2 and negative 1/3. Okay, a couple more slip and slides, or maybe all of them. Number 9 is not a GCF, does not have a GCF, so it's a slip and slide, which means I'm going to slip the 4 to the 5 again. And we're going to have x squared minus 8x minus 20, where now I have a basic trinomial that I can break up into two binomials, where x times x is x squared. Since c is negative, that means one's going to be positive, one's going to be negative. What multiplies to get 20 but subtracts to get 8? That would be 10 and 2. Since 10 is the larger number, it has to go with the sign that b is. So 10 has to be negative and 2 has to be positive. Since it was a slip and slide, we're going to bring this 4 back as a denominator, which means it simplifies 2/4 to 1/2 and 10/4 to 5/2. I'm going to slide those denominators back to the front. So this ends up being 2x plus 1 and 2x minus 5, where I'm going to set both equal to 0. So 2x plus 1 equals 0. We're going to subtract 1 and then divide by 2. So my first x-intercept is negative 1/2. The second one, where I have 2x minus 5 equals 0, we're going to add 5 and then divide by 2. So my second x-intercept is 5/2. Number 10 does not have a GCF, so I have to slip that 4 to the 9. So it ends up being x squared plus 12x plus 36. Now I can break it up into two binomials where x times x is x squared. Since c is positive, that means they're both going to be the same. b tells me that they're both going to be positive. What multiplies to get 36 but adds to get 12? The two terms that come up are 6 and 6. We got to bring that 4 back down as a denominator. They both simplify to 6 over 4 to 3 over 2. And I slide that denominator back to the front. So both of them end up being 2x plus 3, 2x plus 3. And then we set both of them equal to 0, but truthfully, because they are both the same, we only need to set one of them equal to 0, minus 3. 2x equals negative 3, then divide by 2. So this one will only have one solution. That means it's a parabola that is going to cross the x-axis one time instead of twice, because it will never cross the same spot twice. It's only going to touch once. So this x-intercept is negative 3/2. Number 11, all four of these on the very end is what, whenever it's not set equal to 0, so we need to make sure we move anything to set it equal to 0. Number 11, since it's not set equal to 0, we need to move the negative 2. In order to move the negative 2, we have to add 2 to both sides. So this ends up being 3x squared plus 7x plus 2 equals 0. There is no GCF, but I do need to do a slip and slide, so it ends up being x squared plus 7x plus 6. Now I can break it up into two binomials where x times x is x squared. Since c is positive, that means they're both going to be the same, and b tells me that they're both going to be positive. What multiplies to get 6 but adds to get 7, the two terms that come up are 6 and 1. So it doesn't matter where I put the 6 and the 1. This was a slip and slide, so that means I have to bring that 3 back as a denominator. This ends up being 2 over 1, or just 2. And this stays 1/3, so that one will be the slide. So my first binomial is x plus 2 equals 0. We're going to subtract 2 to solve for x. So my first x-intercept is negative 2. The second one will be 3x plus 1 equals 0, where I'm going to subtract 1 and then divide by 3. So my second x-intercept will be negative 1/3. Number 12, to set equal to 0, I need to move this 10x. To move positive 10x, we're going to subtract 10x. Order matters here, so it's 8x squared minus 10x plus 3 equals 0. There is no GCF, so we're going to slip this 8 to the 3, where it becomes x squared minus 10x plus 24. Now I can break it up into two binomials where x times x is x squared. Since c is positive, that means they're both going to be the same. b tells me that they're both going to be negative. So what multiplies to get 24 but adds to get 10? And those two numbers would be 6 and 4. Since they're both negative, it doesn't matter where I put the 6 and the 4. This was a slip and slide, so I need to bring that 8 back as a denominator. 6 over 8 simplifies to 3 over 4. 4 over 8 simplifies to 1 over 2. So after I slide this 4 back, we're going to have 4x minus 3 equal to 0, which we're then going to add 3 and then divide by 4. So my first x-intercept is 3/4. The second set of binomial is 2x minus 1 equals to 0. We're going to add 1, and then we're going to divide by 2, where my second x-intercept will be 1/2. A couple more. To set it equal to 0, we're going to add 5. So 12x squared plus 32x plus 5 equals 0. Since there is no GCF here, we're going to slip that 12 to the 5. So it becomes x squared plus 32x plus 60. Where now it becomes a basic trinomial that I can break up into two binomials where x times x is x squared. Since c is positive, that means they're both going to be the same, and b tells me that they're both going to be positive. And what multiplies to get 60 but adds to get 32, that would be, let's see, adds to get 32. Oh, 30 and 2, that didn't come to me right away. Since it doesn't matter where they go, since they're both positive, this was a slip and slide, so I'm going to bring that 12 back as a denominator. 30 over 12 simplifies to 5 over 2. And 2 over 12 simplifies to 1/6. So my first one is going to be 2x plus 5 equals 0, where I'm going to subtract 5 and then divide by 2. So x equals negative 5/2 is the first x-intercept. On the second set, it's going to be 6x plus 1 equals 0, and then we're going to subtract 1 and then divide by 6. And when I divide by 6, my second x-intercept is negative 1/6. Number 14, in order to set it equal to 0, we're going to move x squared and positive 2. To move x squared, we're going to subtract x squared and subtract 2 to their corresponding terms. So this ends up being 5x squared minus x squared is 4x squared. And plus 7x minus 2 equals 0. And then this doesn't have a GCF, so that means I would slip the 4 to the negative 2. So x squared plus 7x minus 8 equals 0. Now I can break it up into two binomials where x times x is x squared. Since c is negative, that means they're both going to be different, one positive, one negative. What multiplies to get 8 but subtracts to get 7 would be 8 and 1. Since 8 is the larger term, that means it needs to go with the sign that b is. So 8 needs to be positive and 1 needs to be negative. Then we're going to slide or slip that 4 back. It was a slip and slide. So 8 over 4 simplifies to 2, and 1/4 does not simplify. So my first set, x plus 2 equal to 0, all I'm going to do is subtract 2. So my first x-intercept is negative 2. The second one is 4x minus 1 equals 0, which I'm going to add 1 and then divide by 4, which means my second x-intercept would be 1/4.